When we have a probability question in an exam situation, it's really important that we initially recognise the key formula when we're dealing with probability events, and that is that the chance of an event happening is always equal to the number of successes divided by the number of outcomes. So if we always think about successes divided by outcomes. So consequently, if I flip a coin, a fair coin, and I want it to land on heads, the chance of getting heads from a coin is 1 chance in 2. If I roll a dice and I want to get 6, the probability of getting 6 is 1 chance in 6. So we always look at the number of successes divided by the number of outcomes. It's also really important to be able to navigate around a set of playing cards. By way of an example here, you may get a question in the exam that just asks you, from a well-shuffled pack of cards, what's the probability of picking a diamond? So I pick a card at random, I want it to be a diamond. In this case it's a heart, I want a diamond. To actually look at that from this formula point of view, I would say, okay, well, the probability of picking a diamond, I need to work out how many diamonds there are. Now in a pack of cards we know that there are 4 suits. We have clubs, diamonds, hearts and spades. We know that with regards to diamonds, we know that there are 13 diamonds out of 52 cards. So the chance of selecting a diamond is 13 out of 52. But we always ask ourselves, can that fraction be simplified? Yes it can, because 13 will go into the numerator and the denominator. So we can say that 13 over 52 simplifies to 1 chance in 4, which is an intuitively correct answer because there are 4 suits anyway. So the chance of picking a diamond is 1 chance in 4. If a question asks us to find the probability of picking a king, again, just looking at the successes divided by the outcomes formula, I know that there are 4 kings. So the chance of selecting a king from a pack of cards at random would just be 4 chances in 52. Now I know that can be simplified. They're both even numbers. That's 2 chances in 26. And that simplifies to 1 chance in 13. So the probability of picking a king from a well-shuffled pack of cards is 1 chance in 13. Sometimes a question may say, what's the chance of picking, say, a picture card? Now we know that picture cards are jacks, queens, kings. So the probability of picking a picture card, well, looking at a pack of cards, I've got jack, queen, king of the 4 suits. So there are actually 12 picture cards in a pack of cards. So I'd write 12 over 52. That simplifies down because 12 would divide. We could put that as 6 over 26. And that simplifies again to 3 chances in 13. If you can see straight away that 4 will go into both, that's fine. But ultimately 3 over 13 would secure the full marks. The other thing to recognise about probability questions is the fact that there's also a relationship between the chance of an event happening and the chance of it not happening. And to illustrate that, I'd like you to imagine that you've been told that the chance of raining tomorrow is 0.72, and you've got to work out the chance of no rain tomorrow. So, if I think about this, if the chance it's going to rain tomorrow is 0.72, a 72% chance of rain, what I need to work out when I'm calculating no rain tomorrow is just to take that answer away from 1, because either it's going to rain or it's not going to rain. So I can say the chance of no rain is just 1 minus 0.72, and that produces my answer of 0.28. So probability questions are very, very straightforward, providing we use the formula for the number of successes divided by the number of outcomes. Some probability questions are more ambitious, so often you may be asked to roll 2 dice. You've got to work out the probability of getting a 6 and a 6. If something like that happened, we could imagine a situation involving what's called a sample space, and we can imagine, say, a red dice going along here with the numbers 1 to 6. and then say a green dice going down here, the numbers 1 to 6. There we go. And then we can fill in the sample space and say, okay, we got 1 and a 1, 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6. And we could complete that table, and that would actually show us there were 36 different outcomes, of which only one of them is a 6 and a 6. So if you were asked to work out the probability of getting 6 and a 6 from rolling 2 dice, although a lot of students think the answer might be 2 in 12 or 1 in 12, in actual fact, looking at the sample space of 36 different outcomes, we can see the chance of getting a 6 and a 6 is actually 1 chance in 36. So sample space is a nice way of listing all the possible outcomes. We could also use it to find, for example, the probability of getting the 2 dice showing the same number, which would be 1 and a 1, 2 and a 2, 3 and a 3, 4 and a 4, 5 and a 5, and a 6 and a 6. So again, the sample space would come in and say the chance of getting the same number on the 2 dice would be 6 over 36, and that would be 1 over 6. So with probability questions, if you show a nice, clear, concise method work, and you remember that the key formula is the number of successes divided by the number of outcomes, probability questions shouldn't be that difficult. So a question like this comes up in the exam, think clearly, think methodically, think about the total number of outcomes and the number of successes, and hopefully the full marks will be yours. So best of luck for this question from the Collins team.